Was she at school?
No, it's a snow day, so everybody's here. It's all canceled, so they're all playing.
Aw.
It's the middle finger right here
Uh-huh.
in her hand that's swelling up, and she won't move it. So, yikes. So I think it's broken. Okay. Review question number 1. Who's got number 1?
I'll go first.
Okay, that'd be great.
Okay, what is the name of the important statistical result that guarantees that the sampling distribution of the sample mean will be normal if the sample size is large? And I put that's the central limit theorem.
That's what I got.
That's what I had.
That's what I got.
Okay, I'll go for 2. Says, what is the name of the important statistical result that states that when the sample size is large, the mean x will be close to the population mean? And I put the law of large numbers.
Yeah.
Okay, 3.
Number 3. Do you want me to go?
Go. Yep.
Which of the following variables is or are categorical? I had number 2, the randomly selected brand of toothpaste at a convenience store.
I put number 3 and 2.
Okay, I had number 3. I wasn't sure about 2. I put a 2 on question mark.
I have 2. Number 3 is not because it's talking about years, which are numerical, not categorical.
So number.
I'll be right back. Just a second. Years. Keep going. So you're right. 2, 3 would probably not be right because it is age. Sorry, my daughter needs me for a second. I'll be right back. Keep going.
Okay.
All right. I'll go ahead and do number 4. Wait, Kelly, did you do one?
No, I didn't. So I think it's my turn. So number 3, we're going with number 3.
We're going with number 2 for 3.
Oh, number 2. Okay. Okay, so number 4. The mean IQ test score in the United States is 100. 20 randomly selected statistics students took an IQ test, and the mean of their score was 112. Which of these two numbers is a parameter and which is a statistic? Let's see, I did the 100 as the parameter and the 112 as a statistic.
Right.
I think.
Yeah, that's what I got too. I had totally forgotten which was which, because I didn't remember learning about it. But they had it in the
I had to look
review, so. I just had to remember that it's parameter for population and statistic for sample.
Oh, good one.
Okay.
Thanks for that. That helps.
No problem.
I need all the help I can get.
I know.
Some of these are like super hard.
Yes.
Okay.
Yeah, some of them I didn't. Yeah, I know.
I completed everything, and I'm pretty confident, but I might have gotten some wrong. So I'll start with 5 again. Rotham City has 4 distinct neighborhoods. The property values are very similar within each neighborhood, but they vary considerably from neighborhood to neighborhood. One neighborhood has very low property values and another has extremely high property values. Property taxes are usually roughly proportional to the property values. What type of samples should we collect to gauge the residents' responses to a proposed increase in property taxes? So, at first with this one, I was kind of thinking maybe the one where you just take one from each.
Yeah.
But later I was thinking maybe the stratified would be better because you already have these groups.
That's what I picked. This is stratified.
I did stratified. Did you guys for 4 get 112 as a parameter and 100 as the mean?
No, other way around.
100 is the parameter and 112 is the statistic.
Okay, I'll look that up.
And the way you can remember it is that parameter is for population and statistic is for sample.
Thanks. Is it my turn?
Yes. You can go.
Great. I'm sorry to be so crazy, you guys.
Oh, that's okay.
Not
at all.
When designed experiments are conducted in public school systems, researchers typically choose a particular district and randomly select teachers of, say, 4th grade students in that district. The experiment is then conducted using all the students in the selected class. Which type of sampling scheme is implemented? And I said cluster sampling. Yeah.
Yep, that's what I had.
That's what I have.
Okay. It's 7. At a school fundraiser, the name of every student person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which type of sampling scheme was implemented? I said simple random sample.
That's what I got.
Okay.
That's what I got. Okay. 8. A special interest group is conducting a survey regarding wolves in Yellowstone National Park. To adequately gauge opinions on both sides of the political spectrum, the researchers took the list of registered Democrats and selected a simple random sample of 100 people. Then they took a list of registered Republicans as a selected simple random sample of 100 people. Which type of scheme was implemented? And I believe I either put A or D. Let's see, stratified or cluster. I think I put.
I had stratified random sample.
I had stratified.
Stratified.
You'd be dividing your Democrats and your Republicans, so there'd be 2 of your group, and then taking your samples out of those. That would break it down further.
Cool beans.
Is it my turn?
Yeah.
Yes.
Okay. All right. So I can't pull up the question, but I can say the answer.
Okay, that's good.
The mean is 4.771. Did you get that?
Yep.
The
Yep.
standard deviation is 1.912.
Yep.
And the 5-number summary is 0.84, 3.395, 5.15, 5.71, and 10.45.
Looks good.
Right? All right.
Is everybody cool on number 10, creating a histogram?
I did it.
Yeah.
Okay, so
Yeah.
I'm going to move to number 11 instead. Okay. Okay. Do you need me to read the question, or can I skip it?
That's fine.
Okay, so we're looking at our thing here, and it says, what's the value of the number that goes in the marked A table? So what I did was I took all of the numbers at the top for the representative temperature, and I added them together and found the mean of that, which was 38.075. And then I took 38.075 minus 37.91, and I came up with 0.165 for A.
Yep.
Yeah.
Okay, and I'm just going to keep going down for A because I got 0.825 for the one below it, 0.905 for Larry, and 0.085 for Per.
Okay.
Cool.
Does that sound right to everybody?
Yep.
Yeah. Is it
Okay.
my turn?
Yep.
Number 12. What is the value of the number that goes in the positive? So it's b. Let's see. So I basically just took those numbers and squared it, and for b I got 0.681.
Yeah, so I was confused on this because I got the same answer as you because that's what the square deviation says on the top in the yellow part.
Uh-huh.
But when we did it before, we didn't do it like this, right?
Right, this is completely new.
I just kind of followed the equation. But yeah,
Oh.
you're totally right. So I don't know if it would work out either way or...
Okay, I was just making sure I wasn't going crazy.
No.
I do have a question on number 11, though.
Yeah.
Isn't that supposed to be negative?
Yeah, I got -2 on 0.905, but I don't know if it...
Oh, I'm sorry, I forgot to read that.
Okay. But then in number 12, they're all positive because they're squared, right?
Correct.
Okay.
Let me do 13.
Yeah.
What quantity is equal to the sum of the numbers in the square deviations column? And I had none of these is correct.
That's what I got.
That's what I got.
That's what I got too.
Because I added them together, and none of them were the standard deviation.
Right, and the variance, that's not the equation for the variance, so I didn't put that. And it's not the mean, obviously.
Right. So it's just not any of them.
Yeah.
Yeah, normally in the normal column that we did, that would be the variance column, but that's not what it is. So,
Yeah.
all right, great.
Oh, it's my turn again. I got 1.73. Is that what you got?
Number?
Number 14.
Yeah.
I apparently skipped 14. So I don't know. Did everybody else get 1.73? How'd you do it?
Yeah.
Was this the standard deviation?
Yeah.
Okay, so I've got to go look at it.
I can look at it later. It's not a big deal. I just apparently just skipped it. That was weird.
Okay, let's skip that one for now, and when I'm done nursing, then I'll go back and tell you how I got it.
Alright, sounds good. 15. True or false? Under certain conditions, the standard deviation can be negative. That is false.
That's what I
It'll
got.
never be negative because it's always squared.
It's false because it's a distance.
Because it's what?
Because it's a distance.
That too. 16. Who's got 16?
Let's see. I think it's my turn. In the same study, the researchers placed thermoses in the sealed. Let's see, for 16. I wasn't quite sure on this because I wasn't. I was thinking extradural, but then I wasn't like quite positive because the standard deviation is like the smallest. But I wasn't actually positive on this question.
That's what I got too, because the standard deviation was the smallest.
And like the sample was the smallest as well.
I think you're right with the standard deviation part of it.
Okay.
That's my thoughts.
Uh-oh. Okay. I'm back.
We lost Susan.
So you just did number 16?
Yep.
And what did you get?
Extradural.
Yeah, that's what I got too.
Hi, are you still there? I got kicked off.
Yeah,
I
it's
think
your turn.
Which
Just
one
barely.
are we on?
so. For 16, we got extradural. Did you get that, Susan?
Yes.
Okay, so you can do 17.
Okay, in your own words and without using any math, symbols, or statistical jargon, explain what the standard deviation. Do not tell how to calculate the standard deviation, but explain what it represents. It's the measure of the spread from the mean, the very middle of the numbers.
Cool.
Is there anything else I should add in there?
No.
Okay.
On that note, I'll tell you how I got the standard deviation now.
Okay.
I took the biggest number, which was Larry, and subtracted the lowest number, which was Roberta, and that's how I got it.
Excellent. Okay,
So now it's my turn again.
okay.
In your own
Yeah.
words, without using any... Oh wait, you just did that one.
I think we're at 8.
So, 18. Give the 5-number summary for this data. And that would be 2, 4, 6, 8, 12.
No.
What?
2, 4, 6, 8, 14.
Oh, is that 14? Wait. No, it's 12.
I have to disagree with you on that one because when I went back and read the notes, it says that even the outlying numbers
Oh,
would
that's an outlying number.
be the maximum.
Should it be 0 then?
Sorry, I have to answer this.
Okay.
Hey.
Well, should the bottom numbers be 0?
Oh, sorry, I thought you said it was asleep.
Okay, so I guess the maximum is 14 then.
So 2, 4, 6, 8, 14.
If you would take the kids in the
Brenda's word for it.
things right now, I would really appreciate it. Thank you. I love you.
Bye.
Okay, sorry. Is it my turn?
No, I
Yeah.
had a question about if the
Oh.
14th, the highest number, should 0 be the lowest number?
No, because it's not. It doesn't have a marker there. Hold on. Let me go back to my notes. And
So, I didn't understand what that little symbol was that's above 14.
that's a outlying number.
Okay.
Am I making sense or am I just?
No, yeah, that makes sense
No,
to
you're
me.
Okay,
fine.
yeah, it says if there are points above, then they would be the minimum and maximum instead of the whiskers. Do you like my very scientific note-taking there?
Yeah, I like it that way.
Thanks. I worked hard on that one. Okay. So, we're on 19, or are we still debating 18?
No, it's
We're on
19.
19.
Okay. I believe it's my turn. What percentage of the data lies between 4 and 8 hours? And that would be 50%.
That's what I had.
Would that change? Oh,
It would not.
No.
because it's 25 and 75%. And between that is 50%.
Yeah. That is
Sorry,
weird.
what?
So here's the really hard question, 20 through 22.
Yeah, I need like a review on these. So it's good that we're like.
Well, the
Hold
mean,
on, are you being serious or funny?
What?
Are you being serious or funny?
Who? Me?
About wanting
I'm
a
totally
review.
This is a hard part.
Okay. Then I probably did it wrong. Okay. Who's number 20? Is that me? I'll go. estimate the mean of the measured nitrate concentration in Rexburg drinking water. Number 20. Okay. So, what I did for this was I made my little graph, 60, 66.8, 99.5, and 99.7. And I put in the middle, so it says it's 2 standard deviations away. Okay?
Right.
And so I took the middle, I took 2.52 minus 1.59, and I came up with 0.93. And so that was the distance between the 2 points.
Right.
I took 0.93 and divided that by 2, and came up with 0.465. So I took 1.59 plus 0.465 and came up with the mean of 2.055.
That's what I got.
Great.
Well, I added 1.59 and 2.52 and divided it by 2 and got 2.055.
Well, that is faster than what I did, so.
Wait, what did you do?
Not the same
Susan?
answer.
It
You
is.
added those two and divided it by 2?
Yep.
So then I took 0.465 and divided that by 2 to give me the standard deviation in between. So the complete standard deviation then in this would be 0.2325. And I added 1.59 to 2325 and came up with 1.8225. So my mean is 2.055. One standard deviation to the left, I got 1.8225, and then the second standard deviation would be 1.59. If I go to the right of the mean, the first standard deviation was 2.2875, and then the second would be the 2.52. Does that make sense?
Yep.
I think so.
Yeah. I totally just make a lot of nonsense just now.
Well, you lost me with all those numbers, but.
Did you get the same answers?
So, were you giving answers for 2021 and 22?
Perhaps.
Wait, so we're just finding one answer for 20. So is that 2.055?
Yes. So all of that I did to find number 20, and then it just gave me then by doing that I had all the answers for the rest of them, I guess.
Okay, so for 21 I had 0.2325. Is that what you had?
Yeah.
And for 22 it's 2.2875?
And 1.8225.
Oh, there were 2 answers for 22?
Between 2 measured nitrate concentrates. What are they? So
1.822 and 2.288.
So basically one standard deviation between there. And I got 1.8225 and 2.2875. Is that what you said?
Okay, perfect.
Wow.
And then 23, the mean and standard deviation.
0 and 1.
Wait, what?
I looked back at the notes, and when there's not really, when they're just talking about it in general and not with a specific problem, the mean is 0 and the standard deviation is 1.
Cool.
Okay. That's not what I got.
What'd you get?
I just said that the mean was the same mean, which would be 2.055. But I could be completely wrong because I wasn't sure.
Well, the last problem was only questions 20 through 22, so 23 is a separate thing.
Oh, that's what messed me up. Okay. So whose turn is number 24?
I will. What is the probability that a randomly selected student will score above 542.3 on the GMAT? I had 0.5.
So
That's what I got.
I'm just gonna take your word for it because I didn't get this far.
That's what I got.
You want to go through them?
We don't have to. I can go back and just review my notes.
Would you like us to at least tell you how we came up with the answer?
Sure. That'd be good.
Go ahead, Susan.
Okay, take 542.3 minus the 540. Wait a second. I don't know, I'm stumped. All I had written down was my answer. The 600 or the 5?
So I thought about this two different ways. You could do z equals x minus u over q, which would be 542.3 minus 542.3 divided by 120.54, and you kind of come up with 0. So if you put that into your normal probability applet as a z-score for 0, you would come up with 50%.
Yeah.
Or the other way I thought about it is 5.42 is the mean, so 50% is going to be above and 50% is going to be below, and that's just a given.
I like that. Thank you.
Sweet. Okay.
Who did 24?
That was Susan.
Okay.
What is the probability that a randomly selected student will score below 600? So for this one, would you do 600 minus 542.3 divided by 120.54?
Uh-huh.
Yep.
Okay. I don't have the... Okay, I just have the equation. I don't have the answer right with me.
So the answer I got is 0.4787.
That's not what I got.
But don't you have to do the probability with putting the z-score in the probability?
Well, that's the z-score, sorry. And then I put that z-score in.
Okay.
I was giving her the answer to the equation, my bad.
Oh, no, that's fine.
And then once I put that into the normal probability applet, did you guys get below 0.6840?
Yeah.
So we have to have both sides to the left shaded, right? 0.684.
Yeah.
Right, because it's below.
So that's the answer, 0.684.
Okay.
Yay. So, Beth?
Yeah. Okay. 26. What is the probability that a randomly selected student will get over 600? And that's just the opposite, 0.316.
Right.
What I got? Okay, 27. 10%. Find the GMAT scores that corresponds with the 10th percentile. So what I did was I went into the applet and I put 0.1 in the area, and then I got the answer of negative 1.28, and I plugged that into our equation to find x, which x equals u plus parentheses z times q parentheses, which equals out to be 542.3 plus parentheses negative 1.28 times 120.54 parentheses, and I came up with 388.009 would be the 10th percentile.
I got a slightly different number.
What'd you get?
I got 387.768.
Who was that? Beth?
Yeah, and I'm not exactly sure what I did different than you. but my equation was I got negative 1.282 times 120.54.
That could be the difference because my applet only goes 2 numbers.
Oh, really?
Yeah.
Really?
Oh.
So I will recheck that, but it is close. So I'm guessing that's where the difference is.
I wonder if that would mess you up on a test if you only had
It might.
2 numbers.
Great. Now you're gonna make me freak out.
That's weird though that it only does 2 numbers after. Mine does 3.
So we're gonna go with Bess.
Yep.
So 387
387.
point.
After Beth,
387.
is it Brenda after Beth? Yes.
Wait, did we get 387 point what?
768. I'm gonna replug it in and see if it came up different because mine was 388.009. It's such a small difference that I wonder what the difference is. But
And by the time you round it, you might be just fine.
maybe. 28. Oh, I'm gonna get a different answer as well then too. So I did the same thing, only using a positive 1.28, and I came up with 696.591. So what did you get?
696.832.
Okay, I'll double
And then
check.
it was a positive 1.282.
Oh, sorry.
What was that?
You
You got a whistle?
was chewing on my pen and I sucked in and
Oh,
through the cap. I don't know. It just whistled through the cap. Sorry.
buddy.
I did not. It scared me. I about knocked my computer off.
So would the percentile be then 0.0999 for 28?
Then the percentile on the top, the area is 0.9.
Okay.
And then you plug that in, you come up with 1.282.
Yeah, and then we just have the right-hand side shaded. Ugh. Okay, that's what I've got.
It should be everything to the left.
Yeah.
Oh. Well, then I get 0.9001.
Well, it should be the middle and the left that's highlighted since it's 90%.
Yeah, okay. So then how do you find that score? What's the formula?
Oh, so you got to take the z-score and times it by the standard deviation, and then plus that by the mean. That's how you find the score.
Plus the means?
Yeah.
Yeah, so your formula is actually to find x is x equals u with mean plus parentheses z times q. Oh dear. My computer's going to die. I've got to run upstairs.
You just got everything going against you today.
I know, it's like I'm fighting gravity or something like that. Okay. Are we on to 20? What are we on? 29?
29.
Yes.
Is it my turn? You love how I keep can't remember whose turn it is. Well, I'm gonna go. 29. Find the first quartile of the distribution of the GMAT scores. So, quartiles are within one distribution. So I did 542.3 minus 120.54 and came up with 421.76.
What was your equation again?
Mean minus deviation. 542.3 minus 120.54. Coming up with 421.76.
Yeah, I got a different number again, but I think I have a different equation.
What's your equation?
So the first quartile, that's 25%. So we're supposed to find the z-score of 25%, right?
Okay.
And then we have to find the score that goes to 25%. So the z-score that I got was negative 0.674. I times that by 120.54, add 542.3, and I got 461.056.
$461.056.
Yeah.
That's what I had.
Okay.
It must be that app, Brenda.
This is actually making me really nervous.
I don't feel like you always had that problem, though, did you?
No, but I'm using the same applet that I did before.
It's really weird.
I'll figure it out. At least you guys are all agreed though, so that's a good thing.
Yeah.
So for 30, the third quartile is 697.
697 what?
Is that right? 697. 696.8, so you round it up to 697.
Okay, I don't have the same answer, so I'm going to take your word for it on that and check my
Oh, because I don't know if I'm right.
This is for number 30.
Yeah.
Third quartile is 75%. For that, I got 0.674 as a z-score.
What was your third quartile though?
The actual number was 623.544. Oh, is that what you just said?
No.
No, that's not what you said. Okay.
So what it then? So then you put your z-score in, and what do you have shaded?
I don't think it really matters what's shaded because you're just taking the z-score and putting it in the equation.
Because the z-score doesn't depend on what you have shaded. Only the area does. And it will shade that yourself when you put the area in.
Oh, I don't know.
That makes sense?
Yeah.
And then
Okay. Are we on 31?
Yep.
And whose turn is it?
let's see.
I lose track.
Let's go to
sample.
So this one's like the long equation, isn't it?
Yeah.
So what are the mean and standard deviation of the distribution of sample mean scores for all such samples? Oh, oops, I went too far.
So this one actually is a simple, well, for half of it's simple.
Yeah. 31's easy, 32's the big equation, right?
Except for 31, don't we use standard deviation of q divided by the square root of n? Or am I not right on that?
No, that is correct.
Okay. So, did you get for your mean 542.3, obviously?
Yes.
And then for your standard deviation, did you get 31.123?
Nope.
Oh, what the hey? What'd you get?
The standard deviation is 3.873.
That makes more sense. How'd you do that?
So you're taking the regular standard deviation, which is, can't see right now.
120.54.
Right, that one. And then you divide that by the square root of 15. And you got to make sure to make your parentheses correct.
I must have typed it in wrong with my wrong parentheses. Okie dokie. Well, this next one's going to be awesome because I think I've gotten every single answer wrong. So, I won't do that one. I don't think it's my turn anyways.
Whose turn is it?
Beth, it's your turn.
Alright, what's the probability that the sample mean score for a simple random sample of 15 students will be greater than 600? And, oh, here's my equation. So I'm just going to shout out the answer, and then if we all got it right, then we don't have to go through the equation, right?
Yep.
I got 0.032.
Aw,
That is not what I got.
It's not what you got?
I got
That is what you got, Susan?
yes.
Okay.
So, it's just the 600 minus 542.3, and then divide that by the standard deviation that we got in the last question,
Mm-hmm.
and then you'll get the 0.032.
Which is why I'm wrong, because my standard deviation was wrong from the last question.
Gotcha.
Well, that was fun.
Not so difficult. And you're only 15 minutes later than you wanted to be.
Yep.
Oh, we're supposed to do the... Are we
Oh my
supposed to do the quiz together?
Yes. But isn't the quiz the same thing as this?
I think so.
Yeah.
And if you want to go, you could probably just do it later. We went through all the questions.
I'd have to stop the recording though, but we kind of just did it, didn't we?
Yeah, I think so. So we could probably stop recording it now.
Okay. You guys have a wonderful day. I will see you tomorrow.
Okay.
And Quinn is supposed to show up tomorrow.
Okay.
Good luck with your daughter.
Thanks. See you later.